Alright, here we go. We got triangle congruence notes. So we're going to be talking about different triangles and what theorems make them congruent triangles. Like what's the minimum uh, pieces of information that we need to prove that the triangles are congruent. All right, and you'll probably, most classes do a little activity to start this out, so this is probably assuming the activity has already happened. But if not, you should be, I think I'll explain it in a way to where you can follow along. So anyways, talking about congruent figures here first, two geometric shapes that have the same, same exact side lengths and then the same angles in the corresponding locations. Our corresponding parts, these are parts of a shape that are the same location by looking at the markings of a picture or congruent statement. Alright, so like that would be, for example, here CA corresponds to the side FH right there. So that would be a corresponding part just based off of how it's marked. A congruent statement, a statement that is a statement stating that two figures are congruent and that shows the corresponding parts. Okay, write a congruent statement for these triangles. Identify all pairs of the congruent corresponding parts. All right, so the diagram indicates that triangle ABC is congruent to the other triangle here, and we have to pay attention to the order here. So notice here they start at A, they start at the right angle, they go to the double hoop C, or actually no, they go ABC. I'm sorry. So they start at A, they go to the single hoop there. So A, B, C right there. So I need to go in that same corresponding order for the other triangle. So I'm going to start at the right angle. I'm going to go towards the one hoop there, and then I'm going to go towards the other double hoop there. So that'd be F, G, H. And that's kind of how you go and mark your triangles congruent there. So your teacher will probably count off though if you do the incorrect order. So you got to be very careful on the order of these here. It's a lot of attention to detail, I guess. So if we look at what's marked here, you got the right angle A, so that corresponds with the right angle F. You also have the the single hoop right here at B, so that corresponds to angle G on the other figure. So then obviously C corresponds with angle H on the second triangle there. All right, as far as the sides, let's look here. We got side AB. Notice it's marked with 2 ticks. So the other one with 2 ticks is GF. Now as far as the order, you can write FG or GF. Most teachers aren't too picky on that. What do we got here? BC. So that would be 3 ticks there. 1, 2, 3. So then we're looking for the other one with 3 ticks, GH. Put your little segment guy above that. And then we got CA. So that is the one little tick there, so that's FH over here. Okay. Use the diagram shown in which FGHI, so that's the quadrilateral, that's congruent to the other quadrilateral, STUV. Identify all pairs of congruent corresponding parts, then find the value of X. Okay, so it's kind of the same thing here. It's kind of redundant a little bit here, but so notice here we got F right there, and then notice that the next one starts with an S, so those are corresponding. So as far as our angles go, we'll say angle F is congruent to angle S, and if you want to go ahead and mark that, you can do that. So those are those 2 angles there. Whoops, let's do this. Okay, next one in the order that it's going in, you got the G, and then I guess you got T. So angle G is congruent to angle T. Okay, and those are the ones that we're going to set equal to each other there. So I'm going to say 2x minus 7 equals 103, since those are congruent and they're corresponding there. But we'll take care of that here in a second. You also got H is congruent to, what was that, U. And then you also have, last but not least, angle I congruent to angle V. Now as far as all the segments go, you got to be kind of careful on that. So I guess usually I kind of just, what I do is I go in the order that you got right here. So notice here you got FG, so I'm going to locate that. That's how I kind of keep things in track right there. And then ST. So say the sides. So we'll say side FG congruent to side ST. Okay, if I go GH, then I need to go TU. So that would be that side right there. All right, next, I guess we got HI. Where's that? Or, wait. Oh, are they using different letters? Huh. I guess that's supposed to be an I right there. That's kind of weird. Just notice that. I think that's good now. So FGHI. Yeah, so, okay, so anyways, HI. That needs to be congruent to, I guess, UV. Should be this right here. And then the last one, this one's kind of weird. You go IF. That's 4 ticks. And then you could go VS, I guess. So IF congruent to VS. There you go. There's all your corresponding sides right there. So you don't have to do a ton of those usually because it's kind of, it's kind of a pain to write them all out there. But that's all the matching stuff right there. Now as far as, when you have congruent angles, then you can set the two angle expressions equal to each other. So this part here, just add 7 to both sides. Got something like 110. And then x equals, I guess, 55 once you're done. And then I guess they want us to go find angle G, but actually we should know angle G because it's going to be 103 degrees, right? I mean, if you go plug in 55, it should be the same, but yeah, that's really all you got to do there. So that one is already kind of done for us. So anyways, next thing here, third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. All right, and you can verify that by playing with numbers here. If you had like 60 and 70 right there, and then you had 60 and 70 right there, well, remember, all angles in a triangle need to add up to 180. So no matter how many times you do it, when you add those two up, and what is that, 130, the last one's got to be 50 both times, essentially, is what it's saying here. Okay, so if you have two matching angles to the triangles, then the third angles automatically have to match. Okay, there are 5 ways to prove triangles congruent with all these weird symbols here. So we're going to talk about what they mean: SSS, SAS, ASA, AAS, and then this one here, it's HL right here. So I'll talk about how to identify those and how to mark them. So let's get into it here. So whenever it says SAS, that means side, and then angle, and then another side. All right, what's going on here is we are saying that one of the sides is congruent, then you have an angle, and we call this an included angle. I want you to write that in. Included angle. Notice the angle here is in between the two sides. It's right in between there. All right, now as far as how that looks here, you're going to say side, and then angle, and then side, like this here. So here's an example of how that could be marked right over there. All right, so if you have that combination right there, if you have a side, two sides are congruent, an angle in between the two sides, and then you have that third side, well, here, let me say that better. If you have two sides that are congruent here, and the angles in between or included in between them right there, that is enough to prove that those triangles are congruent. That's one of our theorems there. That's one of our combinations there. Okay. Now there's one that's similar to this here, except instead of doing side, angle, side, it's angle, side, side. So that's what that means. Angle, side, and then angle. All right, and I want you to put this, once again, you have an included. You have an included side right there. So that means in between, directly in between your two angles that are marked congruent, you have a side there. And as long as that same order is happening on both of your triangles, then the two triangles should be congruent. So this would be an example of how that could look there. Okay, now you got some other combinations here. This one's side, side, side. So if all three of the sides are congruent to a corresponding side of the other triangle, then you are good to go. Those triangles are technically congruent. So you could go 1, 2, 3. Also, as long as you can get it in that same type of order, I've seen it done like this here, where you'll have 1, 2, and then 3 going on. So this triangle is kind of like going in this direction here, and the other triangle's going in the reverse direction right there. But those are technically, based off of how it's marked, those are congruent. So just know that you can see it like that sometimes. So next one here, you can do angle, angle, side, or sometimes, you can rewrite it in a different order, side, angle, angle. Alright, so the way this looks here, you're going to have two angles that are marked, but then a non-included side would be marked congruent as well. So you could say like this side right here, you could also say this other side going on right here. Okay, as long as it's got that same order. Now be careful, because I haven't seen a whole lot of examples like this. You might see something that's marked like this here, and since it doesn't go in that same order, like 1 hoop, 2 hoops, and then 2 ticks, because this one here goes 2 ticks, or I'm sorry, 2 hoops, 1 hoop, and then 2 ticks right there. So as long as it's not like that, it should be fine. I've rarely ever seen that before, so I wouldn't stress too much. But it's got to be that same type of order if you go around the triangle. So I think that's what that part means up here, where it says do not pick up your pencil when you're like going around the triangle. So that's kind of what that means there. Alright, the last one here that proves triangles are congruent, this is hypotenuse leg. Alright, and this right here, hypotenuse, that's always the longest side of a right triangle. So first of all, you have to assume that this is a right triangle. And then if it's a hypotenuse part of the right triangle, like the hypotenuse, that's the longest, right? So if you have the longest side and then you have another leg right there being congruent, then those would work out there. So here's how it would look. You would need some right angles. You would need the hypotenuse marked congruent, and then one additional leg. And that's it there. Now, no matter where you put the leg, should follow in that same order, so the leg can go anywhere. Okay, here's the thing too. I don't know if this is, no, it doesn't come up here on this next part. You need to also know, or be at least familiar with, the non-congruent combinations. Alright, if you have 3 angles, so angle, 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 you can make that in any size you want and keep all the angles the same. So like if you could say this is an equilateral triangle, you could say all these angles are 60 degrees and then all these angles are 60 degrees. No matter what, the angles are 60 degrees, but not necessarily all the sides are going to be congruent. So that's an example of that. The next one's a little tricky to explain why it's not, but angle, 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 and then you want to go side, side, angle. Okay, and this one's kind of tricky here. It's kind of even hard to draw. I'm trying to remember the best way to draw it here. So it'd be like side, then angle. Oh yeah, side, side, angle. I'm trying to remember the best way to draw it here, but you'll have kind of like this bigger triangle, kind of like this here. And then, here, I need to make it more like this. Yeah, anyways, it's kind of hard to draw. I'll have to come back to that here in a second and pull it up on the internet. How to draw that. But anyways, those are the non-congruent combinations. Here, let me search it real quick on my laptop. Here we go. This is a good example here. So I'm going to try to sketch what they have here on the computer screen that I just found right here. So let's say that this side here was 8 right here, and then maybe this is 31 degrees, and then maybe this is 13 right here. Though there's two different ways you can get that 8 going. You can get it like that, or you can actually draw it in such a way where the 8's kind of going like this right here. So you have like an isosceles triangle here. So sometimes they'll draw the rest of this. They'll draw it like kind of like dotted, I guess. So I'm going to try and make it, yeah, that's pretty close there. And that's kind of what it looks like here. So you could have a big triangle kind of like this right there, and you got the 8, the 13, and the 31 degrees. Or you could have the 8, the 13, and still the 31 degrees. So there's two different ways you could draw it out there. So that kind of messes it up there, and that's why they say it's not a congruent. Not necessarily always going to be congruent there. So side, side, angle, and then angle, angle, angle there. Usually you guys are pretty good at remember the angle, angle, angle. The way I remember it for this one right here, the side, side angle, is if you spell it backwards, you make a bad word, I guess, or not an appropriate word in school. So that's kind of my goofy way to remember it. Now, the one thing you need to know though here is the side, side angle is actually the hypotenuse leg is an example of the side, side angle, but it's a very specific one. All right, hypotenuse leg, technically, if you look at it, yeah, it's side, side, and then you got the non-included angle there. It's just a very specific case that always works right there. So the hypotenuse leg, whenever you see a right triangle, look for hypotenuse leg. If it's not, then don't worry about it. So be kind of careful there on that. Side, side angle is not always congruent unless it's a right triangle, essentially. All right. This next part here, we're going to practice. Doing our, recognizing the different types of triangles and then telling whether they're congruent or not. So we just kind of go through it all here. So let's check this out here. For each pair of triangles, tell which postulate, if any, makes the triangles congruent. So notice here on this one here, you got 1, 2, 3 going on. So then in the other triangle, you got the 1, 2, 3 going on as well. So these triangles are congruent. So yes. By side, side, side right there. All right, notice they're going, a little bit different. They kind of look different. One's like kind of standing up, and then one of them's, I guess, on its side there. All right, now, this one right here, this is kind of tricky here because they only mark 2 things. But there's this thing called a shared side. So I want you guys to write that, shared side. And whenever you have a shared side, you can always assume that those shared sides would be congruent to one another. So this here would be side, side, side. You have one side, second side, a third side. You got the same thing on the other triangles. One side, second side, third side. So you can kind of go through that. So the key thing on that one, shared side going on. So yes, those are congruent. Look at this one here. Notice they look like right triangles, but there's nothing marked about it being right triangles, so we can't assume it. But it's not going to make that big of a difference here, because notice here you got the side, angle, side, and then notice on the other one, in that corresponding order, you got side, angle, side. So those are congruent there. All right, next one here. This is another one here where you have a shared side. So I'm going to go ahead and mark those congruent right away. All right, now if you look at it, you see side, side, angle. We just said, oh, okay, that's not going to be a situation where those are congruent. But there's that one case of the hypotenuse leg right here. And since these are right angles, this one technically is HL, hypotenuse leg on that one. Okay, next one here, let's see what we got. Now this one's very, very tricky here. A lot of you guys want to look at this and say, oh yeah, these 2 angles down here look congruent. Well, they're not marked necessarily, so you got to be really careful here on this one. There's only 2 things that are marked. There's a right angle, and there's only one side. So I'm going to say this is not congruent. If you want to put a reason, you could say just two marked things, I guess. Angle side doesn't mean anything. Okay, now to follow up with that, this one's kind of tricky here because there's only two things marked, but I'm going to say yes, these are. I'm going to say yes because of side, angle, side. Okay, so obviously the sides are marked here, but the angle here in between, this is where you got to be careful here. The angle, those angles are assumed to always be congruent. You can always assume vertical angles to be congruent, even if they're not marked. If you're looking back at the other example here, these are not necessarily vertical angles, so that's where you got to be really careful. There's only two things marked, but if you ever see vertical angles, you can go ahead and mark those congruent in addition to the shared sides. So we've kind of seen the things that we need to mark: shared sides and then vertical angles. So be careful there on that one. Let's see what we got going on here. Just like we said just a second ago, you can always mark your shared side as congruent. So here you got side, angle, side. Notice the other triangle, side, angle, side as well. You got that shared side. So side, angle, side on that one. All right, next one here. Let's see what we got marked. You got two sides, but then you got a shared. So I'd say yes because of side, side, side. So really, it's just practice and recognition of this type of stuff here. So let's do a couple more here. I think we got another page. Here they have the vertical angles already marked for us here. So you have side, side, angle, side, and then side, angle, side in that same order there. So this one's good. Okay, let's see what we got. Ooh, okay, this thing is crazy here looking. So we need to identify the triangles. There's a lot of triangles going on here. So we're talking about triangles C, D, E. Okay, with the other triangle A, B, F. Okay, so those are those two triangles that we are looking at there. So I'm going to go back and erase that here. Notice here you got an angle, side, angle, and then notice here that you have an angle. Wait a minute. This is strange. Oh, okay, sorry, I was looking at something. There's like an extra marking here that was throwing me off there. But then again, you got angle, side, angle right there. Sorry, I saw this angle over here and I was kind of confused by that for a second. But since you have angle, side, angle, and then angle, side, angle, notice the side is directly between the two angles. We say angle, side, angle on this one. Okay, next one here. What do we got here? RTS. So we got angle, angle, side. We just learned that that was one right there. And then notice here you got angle, angle, and then side right there. So as long as you retain that same order, you should be okay. So angle, angle, side, angle, angle, side. So that one's good. Let's see what's going on here with this one. I guess based off of what's marked here, you could go angle, angle, side, angle, angle, side right there. But you could also go ahead and highlight the shared side right here, and then you could go and say side, angle, angle, side, angle, angle. So there's different ways you can do that one there. There's actually more than enough information to say that this thing here is congruent. Now be careful, you don't want to put here, you don't want to say side, side, angle, or angle, angle, side, depending on the order that you want to do it there. You want to be careful because that one doesn't necessarily always prove that triangles are congruent. So that one's got to be angle, angle, side. Be careful on that one. Never put SAA or ASS on one of those. Okay. Look at this. Sometimes they're going to give you different things like maybe certain sides are parallel, or maybe you got a bisector or something. So like this one here has got an angle bisector. So if we have an angle bisector, go ahead and mark your angles congruent. And then I notice here we also have a shared side. The BP is the shared side. So I'm seeing side, angle, side, and then side, angle, side again. So there you go. Let's see what's going on here with this one. You got a right triangle because it's marked a right angle right there. So this could be hypotenuse leg. Let's double check there. So you got the hypotenuse, you got the leg. That's good to go. Remember, hypotenuse leg, that is a specific case of side-side angle that works. But it's only when it's hypotenuse leg. Whoops. Okay. Next one here, we have DCE and then BAE. And look here, only two things marked, but remember you got to look out for shared sides. You also need to look out for vertical angles here. So this one here, be careful. Just because it's a right angle doesn't necessarily mean it's always hypotenuse leg. This one here is actually angle, side, angle, and then angle, side, angle. So you got to be kind of careful on that one. And I would put a star next to that one. It's not HL. Because the hypotenuse wasn't even marked on that one. So, all right, this next one here, actually they didn't give us the triangles here, so we got to write them out ourselves. Notice here you got a shared side though, so it looks like we're going to go angle, side, angle, and then angle, side, angle. Now we'll have to write out the triangles ourselves. Now we need to make sure we line up the corresponding spots correctly, and this is kind of tricky here. So looks like we're starting here by angle E, I guess. But here I need to highlight this triangle here. So that would be angle E of the triangle that I have highlighted right there. So we're going to go triangle E, and then I guess L, and then G down there by that thing that kind of looks like a right angle, I guess. And then I need to go in that corresponding order on the other triangle here. So I need to look for the first hoop. So I need to go L, and then E down to the double hoop, and then U. And then there you go. Okay. And then I guess this next lesson here starts some of the proofs. So we're going to go ahead and cut that off there.